Welcome, my students. We will now start the practice questions of classified past paper questions on chapter number 9. So, question number 2 says, all mammals have a double circulatory system. Figure 1.1 shows part of the human double circulatory system. And this is the graph of the figure. A, name a muscular wall that separates the left and right sides of the human heart. Okay, he needs you to mention the part of the muscular wall that separating the left and right sides of the human heart. Surely it is the septum. Here is the septum. If I draw it like this, for example, in order to make it easier and closer for you to understand it, here there is a muscular wall, which is known as the septum, that is separating the right side from the heart, that have deoxygenated blood from the left side that has oxygenated blood. Sorry. So here is the septum. Okay, this is the septum exactly. This is known as the septum. Okay, so here is the septum. And dividing the heart into two sides, as we mentioned last practice questions, that here we have right side and on the other hand we have a left side. Sorry, right and left sides. The right side is dedicated for oxygen poor blood, oxygen poor blood, or deoxygenated blood. While the left side of the heart is dedicated for the oxygen-rich blood, or oxygenated blood. So in order not to have those oxygenated and deoxygenated mixed, so there is a septum in order to separate them from being mixed. So the answer here, name the muscular wall, it is the septum. Okay. BI, describe what is meant by the term double circulation. Yeah, as we mentioned before, that the blood flows through the heart 2 times in one complete journey or in one complete circuit. So the blood flows through we can say visit, okay, the heart, okay, twice or 2 times, okay, for one complete journey, for one complete journey or for one complete circuit. This is the definition of the double circulation. If you are looking back here a little bit, how it visits the heart wires. Firstly, the blood is being received by the superior vena cava and inferior vena cava. Then it will be drained its content into the right atrium. Then it will flow into the right ventricle. Then the right ventricle will pumping the blood through the pulmonary artery that will be divided into right and left branches for both lungs. And on the lung, the gas exchange will takes place, and the blood will not go to the body, but will back again to the heart. This is the pulmonary circulation. So this is one visit. Okay. So another one, the blood will be flow from the left atrium to the left ventricle. Then it will be pumped through the aorta to all of the body parts in order to be supporting and giving the nutrient to the cells, the water, the vitamins, the monosaccharide, the amino acid, the fatty acids, the hormone, the enzyme, every single thing that the cells or the tissues need. And the deoxygenated blood, after all of those nutrients is being used up by the cell, will be returned back through the through the superior vena cava and the inferior vena cava and drain back into the right atrium. This is the systemic circulation. So we have a double circulation. State one advantage of the double circulation. Surely in order, one of the most important thing that what is the benefit of returning back the blood from the lung to the heart and be pumped by the muscular wall of the heart. Here is the left ventricle, that has a thicker wall, in order to support the blood all over the body. So it's a larger or a far proximity. So even if you are looking here, the muscle of the left ventricle here is much thicker than the muscle of the right ventricle. Why? In order to pump the blood with a higher blood pressure to all of the body parts. So we can say here that the first advantage is higher blood pressure, to gain higher blood pressure. So this number one. We can even say much more, So in order to have even increase in the flow rate of the blood, in order to have more, pressure to be allowed to be pushed or to be given to all of the body parts. All of those are accepted, valid marking points. Let's move to the next page. Table 1.1 describes some of the structures of the human circulatory system shown in figure 1.1. Complete the table. One row has been done for you. This is the description, and this is the name of the structure, and this is the letter on the figure. I prefer, as a strategy in order to solve such questions, is to label. So I'll back a little bit, finishing the labeling. Then it will be very easy to answer everything here. Yes. So here, J, it is a branch to the lung. This is to the lung. And here is the pulmonary artery. So this branch is, it is the branch of the pulmonary artery. Pulmonary artery. K is after the blood is being oxygenated or the gas exchange occurred in the lung, the blood will be returned back to the heart via pulmonary vein. So this is the pulmonary vein. Okay. Of course, P is the aorta, the blood leaving the heart from the left ventricle through the aorta to all of the body parts. B is the aorta. Okay, this is the biggest and the main artery in the body. O here referring to the place at which the gas exchange take place. Okay, so O here is the circulation of the blood inside the blood vessels. So, okay, we can even see this. This is supposed to be the lung, but inside the lung there are the alveoli. There are the alveoli. The alveoli, okay, and even we can look for this when we are solving the questions, okay. We can say lung as well. Well, this is the left lung and this is the right lung. We can say right lung as well, because it's not precisely, labeling or not precisely pointing to one thing in order to be defined here. This is maybe as well right lung. But of course, the gas exchange occurred on the actual respiratory surfaces, and the actual respiratory surfaces are the alveoli. So N here is a blood vessel that comes from the body to the heart, and it came from the lower body part. So this is supposed to be the inferior vena cava. Inferior vena cava. Inferior vena cava. That taken the deoxygenated blood from the lower body part in order to return it back to the right atrium. Yes. Here, a blood vessel, okay, which is a branch from the aorta, okay, that take the oxygenated blood surely to the, yes, to the kidney. And of course, this is supposed to be renal artery. Renal artery. Renal means kidney. Artery. Because it takes the oxygenated blood from the aorta to the kidney. And the deoxygenated blood that will be comes from the kidney and will be taken via the inferior vena cava and move up to the right atrium. Surely it is the renal vein as well. Okay. So we labeled everything so easily we can find out the answer for this part of the question. Okay, the heart chamber with the thickest muscular wall, surely it is the left ventricle. It is the left ventricle. And it was the letter C in the previous page. Okay, blood vessel that carries oxygenated blood to the heart. Of course, the pulmonary vein. Pulmonary vein. It was labeled K. Okay. So, blood vessel that carries oxygenated blood away from the heart, surely it is the main blood vessel, okay, main artery, it is the aorta. And it was labeled P. Blood vessel that carries blood away from the kidney, this is the renal vein, renal vein. And it was labeled with the letter M. Here, blood vessel with the largest lumen, yes, it is the vena cava, the biggest, okay, or the main vein in the body, the vena cava. Sure. So, they describe how blood is transported from the vena cava to the lungs. You may use the letters on the figure in order to show your description or new description. So the blood transported from the vena cava to the lung. It's very easy. Okay. So first of all, he now would like us to describe the pulmonary circulation, which is very easy. So, number one, the blood. Okay. He say from the vena cava, so we'll start from the vena cava. Start. Okay, and end up in the lung. So the blood entered, okay, the right atrium, okay, the blood received in the right atrium from, of course, the vena cava, from vena cava, of course, from the superior in the upper body part, and from the inferior vena cava, from the lower body part. Okay, so when the blood received by the atrium, then the right atrium will be contracted. Then the right atrium okay, will be contracted. When the right atrium contracts, then pushing the blood through the or to the close proximity, which is the right ventricle. Okay. Surely, when the right atrium contracts, pushing the blood to right ventricle. Okay. Of course, when this happening, the tricuspid or you can say the atrioventricular valve, okay, open, and blood flows into right ventricle. Then the right ventricle will contract, okay, the right ventricle will contract, pumping the blood, okay, to the pulmonary artery. Of course, towards or to the lung. Okay, so the pulmonary, while the ventricle contract, okay, when the right ventricle contract, the right ventricle, I need to add a word here, when, okay, yes, when right ventricle contract, then contract, okay, then the flaps of the atrioventricular valve will be closed. The flaps of the atrioventricular valve, or you can say, this is much more precise, the tricuspid valve will close, preventing backflow of the blood to right atrium. Okay. Okay. In the same time, they pulmonary. In the same time, the pulmonary valve, which is a semilunar valve, okay, open to allow, okay, flow of blood to the lung. Okay, so this is the complete answering for this question. Let's move to the next part of the question. Yes, doctors recommend that healthy diet can reduce the risk of the CHDs or the coronary heart disease. Give one other lifestyle improvement, okay, patients can make that can reduce the risk of coronary heart diseases? Yes. Actually, there are many things. One of them, they can stop smoking, for example. The patient, if he is a smoker, he has to stop smoking. If he's not doing exercise, he have to do regular exercise. Regular exercise. Okay. He have to reduce the stress. All of those are ways. You just need one, we mentioned 3, and we can even add more. So, double I, sometimes surgery is required to treat coronary heart disease. Describe one named example of surgery that can treat the coronary heart disease. Actually, we have many. One of the examples is the stent angioplasty. Okay, they are using the stent. The stent is a mesh of tube, which is used as support for the damaged or for the plugged coronary or the plugged branch of the artery. How can we use this? Actually, this is a small mesh tube, which is the stent. Okay. First, we have to have the catheter or balloon catheter. Okay, use a balloon. Okay, balloon catheter. Okay, to be inserted to the defected artery. Defected artery. Okay, then inflate the balloon. Surely inside the catheter, inside it, okay, there is this is supported by, because it's according to the technique of the surgery itself. So to be much more precise, we have to say with, and that will be much more precise, with the stent. Okay, then inflate the balloon and keep stent in the defected place, defected part of the artery. Right after this, we will deflate the balloon and remove it. Then the catheter will be used as a support for the damaged, the catheter. The stent will be remains and will be considered a support. The stent. Okay, I'm sorry. This is the stent. Will be remain as support. This is the first technique. Okay, you just need 2. We mentioned many. 2, 3, 4, 5. I can even add another. Okay, in order to extend my explanation and to deal with this, or to make you understand more. We have also the bypassing. We have the bypassing, or the bypass. How can we do the bypassing? Actually, it's another technique. Okay, we are using a shunt blood vessel, jointed or grafted in order to replace the artery. It is a shunt blood vessel. Mostly they are taken vein from the patient himself. Okay. In order to be grafting or grafted to replace the damaged artery. Here there are two things that have to be put in consideration, that the vein should be from the patient in order to reduce the tissue rejection, not to be attacked by the antibodies of the same person and not to cause any catastrophic consequences. Because if it's being transplanted from a donor, for example, that is not matching with the patient himself, so the immune system of the patient will start attacking this grafted or transplanted vein, because it's not part of the body and there is no matching, so we'll start to consider it as a foreign body or an invader, and will start causing antibodies, and antibodies will start attacking it and destroy it. So this is one of the points that have to be put in consideration. So number two also that have to be in the consideration, the surgeon have to choose the proper directions, because as you know, arteries do not have valves, because there is no need for them to have valves, because the high blood pressure that flowing inside them, because they are taking the blood away from the heart, and the blood moves out of the heart with a high blood pressure, so there is no need in order to have valves. Okay, valves, they are being there in order to be sure that the blood moving only in one way towards the heart, and in order to prevent the backflow of the blood again to the heart. So the surgeon have to be sure that. I'll just make this to you in order to find it out. If, for example, the surgeon has two blood vessels or two veins, and he's supposed to choose one of them in the operation. Okay, this is blood vessel A, for example, and this is blood vessel V or B. So, okay. So here, for example, to the heart, and here to heart. This is blood vessel A, this is blood vessel B, okay, and the surgeon has to choose between both of them, or to put in mind the direction of the valves. So the valves here are pointing upwards or towards the heart. Okay, this is the semilunar valve that are present in the veins. No need for them to be in the arteries. And this is the flaps, or the semilunar valves are pointed downwards. Okay. Here another one. So if the surgeon chooses A, then it will be a successful operation. It will be a successful operation. Why? Because this is correct. Because the direction of the flaps, here in A, direction of the flaps, of course the flaps of the valve, okay, is towards the heart. So the blood will move to the correct way, or to the heart, without being any resistance. But in case here of the blood vessel V, or the vein V, this is truly, if it's being chosen, it will be wrong. Reason, because the direction sorry, the direction of the flaps, direction of the flaps, of course, of the valve, are in opposite, or upside down, upside down. So will resist the flow of blood. So the vein may be ruptured, may be burst, or rupture. Why? Because the vein is delicate, because the muscles or the smooth muscles that are found in the walls of the veins is smaller. Okay, maybe burst. Why? Because the vein has, okay, small muscular wall, or you can say thinner, will be much more precise. Thin muscular wall, so will not withstand, okay, the blood pressure. Okay, so we solved today one of the questions of the classified past papers on chapter number 9. So let's see you inshallah next time. Till then, I wish all of you to stay safe and stay blessed. Goodbye.